Welcome back to iTeachCybersecurity Academy, where we make cybersecurity simple, useful, and practical for everyone. In the previous modules, you learned what network forensics is, how network attacks are detected, and how analysts recognize abnormal behavior during security incidents. In this module, we shift from theory into the tools that make network forensics possible. This is Module 3, Network Forensic Tools and Practical Workflow. In this module, you will learn about the different categories of tools used by network forensic analysts, what each tool does, how it works at a high level, and where it fits within the network forensic investigation process. Rather than learning tools in isolation, you will understand how these tools work together, from detection to reporting. By the end of this module, you will know which tools are used at each stage of a network forensic investigation, and which tools you will be working with next as we move into hands-on analysis in later modules. Before discussing individual tools, it is important to understand the network forensic process as a whole. Network forensics follows a structured workflow that begins with detection, moves into data collection, continues through analysis and correlation, and ends with reporting and defensive improvement. Each phase of this process requires specific tools. Using the right tool at the right stage ensures that evidence is collected properly, analyzed accurately, and documented clearly. In this module, tools are organized by function, not popularity, so you always know why a tool is being used. Detection and alerting tools are used at the very beginning of a network forensic investigation. Their main purpose is to identify suspicious or malicious activity and notify security teams that something may be wrong. These tools continuously monitor network traffic and system activity, looking for known attack signatures, abnormal behavior, or violations of security policies. When suspicious activity is detected, alerts are generated to trigger further investigation. Common examples include intrusion detection systems and intrusion prevention systems, such as Snort and Suricata. These tools inspect packets as they move across the network and compare them against predefined rules and signatures. While they are excellent at identifying potential threats, they do not provide complete forensic detail on their own. At this stage, the key question being answered is not what exactly happened, but rather, should we investigate this further? This naturally leads to the next phase, collecting detailed network evidence. Once suspicious activity has been detected, investigators need access to raw network traffic. Packet capture tools are used to collect and store this traffic for forensic analysis. Packet capture tools such as Wireshark and tcpdump record network packets at the interface level and save them as packet capture files, commonly known as PCAP files. These tools work by monitoring network interfaces and capturing traffic without interfering with normal communication. Packet capture is critical because it preserves evidence exactly as it appeared on the network. Investigators can later examine headers, payloads, protocols, and communication patterns to understand how an attack unfolded. Packet capture tools answer the question, what traffic actually moved across the network? Once packets are captured, the next step is making sense of them. Packet analysis tools are used to interpret captured network traffic and turn raw packet data into understandable information. These tools allow analysts to filter traffic, decode protocols, and reconstruct complete communication sessions. Wireshark is one of the most widely used packet analysis tools. It enables investigators to follow individual network streams, view full conversations between systems, and identify suspicious commands, credentials, or data transfers. Through session reconstruction, analysts can see how attackers interacted with systems, moved laterally across the network, or exfiltrated data. This stage is where attacker behavior becomes visible and understandable. Packet analysis answers the question, what did the attacker actually do on the network? Once this behavior is understood, investigators need broader context from other data sources. While packet captures show detailed network activity, logs provide context about how systems and security devices responded to that activity. Log collection and analysis tools centralize logs from firewalls, servers, applications, and security systems. Tools such as Splunk, Graylog, and the ELK stack ingest log data, index it, and allow analysts to search and correlate events across multiple sources. These tools help identify patterns, confirm timelines, and detect activity that may not appear in packet captures alone. Log analysis helps answer questions such as when access occurred, which accounts were used, which systems were affected, and how long the incident lasted. It is especially useful for identifying trends and repeated behaviors over time. At this stage, investigators begin connecting individual actions into a meaningful timeline. Network flow analysis tools focus on traffic summaries rather than full packet contents. Technologies such as NetFlow and IPIFX record metadata about network communications, including source and destination addresses, ports, protocols, and data volumes. Flow analysis tools are useful for identifying traffic patterns, spotting unusual data transfers, and understanding communication relationships across large networks. While they do not capture payload data, they scale efficiently and provide valuable high-level visibility. Flow data helps investigators understand the scope of an incident and identify systems that may require deeper analysis using packet captures or logs. At this stage of an investigation, analysts must combine evidence from multiple sources into a single, coherent narrative. Evidence correlation and timeline analysis tools help align events across packet captures, logs, alerts, and flow data. Many SIEM platforms provide built-in correlation capabilities, but investigators also perform manual timeline reconstruction to validate findings. This step ensures that conclusions are accurate, defensible, and supported by evidence. Correlation answers the critical question: how do all these events connect into one incident? Once this narrative is complete, the investigation moves toward documentation and improvement. The final stage of network forensics involves documenting findings and communicating results. Reporting tools are used to create structured incident reports that explain what happened, how it happened, what evidence supports the findings, and what actions should be taken. These reports may be shared with technical teams, management, compliance officers, or legal authorities. Clear documentation ensures accountability, supports decision-making, and helps improve future defenses. Reporting transforms technical findings into actionable knowledge. Network forensic tools are most effective when used as part of a coordinated workflow. Detection tools identify potential incidents. Packet capture tools preserve raw evidence. Analysis tools reveal attacker behavior. Log and flow tools provide context. And correlation tools connect everything into a complete story. Understanding this workflow prevents a common beginner mistake: using tools without understanding their purpose or timing. In this module, you learned about the major categories of network forensic tools, how they work, and where they fit in the network forensic process. You explored detection tools, packet capture and analysis tools, log and flow analysis tools, evidence correlation techniques, and reporting tools. Don't forget to like, share, and subscribe to iTeach Cybersecurity Academy and turn on notifications so you never miss a lesson. Continue with iTeach Cybersecurity Academy.